This lesson is about the basics of angles. So our focus on this lesson is to be able to classify and name any angle, to be able to identify the vertex, the sides, and whether points are interior or exterior. So let's start with what is an angle. By definition, an angle starts off being a ray. So I'm going to call this ray AB. All right, starts at A, passes through B. If I draw another ray off of that endpoint and call this ray AC, that forms an angle. So by definition, an angle is an object that is formed by two rays that share a common endpoint. Okay? Next, how do I classify angles? So we're going to classify angles in one of four ways. We're going to talk about acute angles. Those are angles that are less than 90 degrees but greater than 0. Right angles, which are 90-degree angles. Obtuse angles, which are angles that are larger than 90 but less than 180 degrees. And then if the angle is a straight angle, it's 180 degrees. Essentially, that's going to look like a line. All right, so on these first examples here, based on perception, so by looking at the picture, what kind of angles are these? The first one looks like it's greater than this space inside here, looks like it's greater than 90 degrees, so we're going to call this obtuse. That's its classification. This angle looks like a right angle, so we're going to call it a right angle. It looks like 90 degrees. The next one, they tell me is 4 degrees. Well, 4 degrees is acute. And then the last one, 146 degrees, that angle would be obtuse. Okay? So, how do I name an angle? I name an angle by one of three ways. Our default, our go-to, is always using 3 letters. But oftentimes I'm able to name, especially single angles, in different ways too. So I'm going to start us off by naming this first angle using 3 letters. I can call this angle, make sure you have the symbol, PQR, or I could call it angle RQP. No matter what, notice how the vertex was right in the middle. Okay? The vertex is that common endpoint. So notice how that vertex is right in the middle. Okay, another way that I could name this angle, because there's only one angle at the vertex, I could call this angle Q. And because they give me that number inside here, I could also call this angle 4. So let's take a look at this second one here. Start with the 3 letters. So I've got angle LKJ or angle JKL. There's only one angle there, so I can name it by its vertex, angle K. And there's a, whoops, sorry about that. Still working on my screen sensitivity here. Another way would be to call it angle 1. All right. Now, the vertex of an angle, as we described before, the vertex is that actual location where the angles share that common endpoint. Okay? The sides of an angle, remember how an angle is formed, are the rays that make up the angle. So, in the next examples, they want us to name the vertex and name the sides. All right. So, for vertex, all that I'm going to do is name a point, K. For the sides, I know I have to name these rays, so I'm going to call it KJ and ray KL. Remember, when naming a ray, we have to start with the endpoint, include a point that it passes through, and it must have the symbol on top of it. Okay, let's try the second example here. I notice this angle, IHG. I know the vertex is at H. That's the common endpoint. And I know that the sides are rays, HI, and ray HG. Every angle must have a vertex and must have sides that are rays. Okay? All right, next set of examples say name all the angles that have V as a vertex. All right, so I see V right there. I notice the big angle, SVQ. I'm going to start with that. Angle SVQ has V as a vertex. Now that's the big angle again, right there. I'm tracing with my cursor. Okay? I also know that there are two smaller angles inside of angle SVQ. So I can say another angle that has vertex V would be angle 4, and another one would be angle 5. All three of these angles have V as a vertex. Okay, let's go to the next picture. Again, see the big picture first. So I see angle GVI. I know that angle GVI is also made up of angle 3 and angle 4, and all three of these angles have V as a vertex. The last thing that we want to talk about is interior angles versus exterior angles. So if I go down to the picture, I think this is more or less common sense, guys. If I look at an angle, I think about the rays extending out, and can this point be on the inside of the angle? Inside means interior, outside means exterior. So in this first example, there's the angle. See my cursor there. I notice point P is outside of that angle, so I'm going to call point P exterior. On the second example, point P appears to be inside the angle, so I'm going to call that interior. This last example, I notice point P is on this ray of the angle. So it's not inside the angle. It's not anywhere outside the angle. On this one, I would say it is on the angle. All right. Hope this helps. Do your work. Let me know if you have any questions.